This meeting is being recorded.
So let's take a look at Chapter 8, Problem 10. We are asked to draw a mechanism for each of the following transformations. So a transformation we know is when we're changing one functional group to another. We're transforming our molecule. So in each of these cases, A, B, and C, we will see where you go from an alkene and we see the process of hydrohalogenation. So these treatments of HX will add in a Markovnikov, right? Markovnikov fashion across the pi bond for our alkene here. So, so initially, what we'll see with A, I'll go a little slow with the first one, and then we'll see a pattern. So I'll go a little quicker with B and C. In our first step here, we have our alkene, and we can really just think of it as reacting with HBr. We have dilute HBr. Let me see here. Let's grab our proton and then shift over and create our nucleophile here. So in our first step, we're going to end up with this product here, and we're going to have creation of a secondary carbocation, and that will be converted through a rearrangement to, or rather, yeah, with a hydride shift. So this hydrogen here, I'll color code this in green, will jump over here, and what we'll have created is a tertiary carbocation, so even more stable than a secondary, which is even more stable than a primary. So we have this hydride shift here. All right, so now we have our tertiary carbocation, that nucleophile, that bromide ion that was created in a previous step, that will now attack our carbocation and our final product. I'll change color one more time here. We have our six-membered ring, our methyl group, and then we've added a bromine to this site here. All right, so let's take a look at these next two reactions. So we're going to see, like I said, a pattern that results here. So in our first step, we're going to have protonation of our alkene. So we have HBr, so our double bond, right, grabs our proton here. These electrons shift over. Now we have created our secondary carbocation again, and we see there's, right, I'll color code this hydrogen here. We'll perform a hydride shift, and then our next step here has become a tertiary carbocation. So again, more stable. And what do we have? We have our bromide that was created previously. Once again, we'll now attack this site here. So we have our nucleophilic attack, and then our final product, once again, will look something like this. All right, so that's B, and let's jump to C here. So instead of HBr, hydrobromic acid, we're going to use dilute hydrochloric acid here. All right, so notice now the alkene, the double bond, is within a ring. So our product will be a cyclic structure. But we're going to see again the same pattern. So first we will protonate the alkene. So we'll grab that. We'll create our chloride ion in this step. So now we have protonated our alkene and we have created a secondary carbocation. And what happens here is not a hydride shift, but a methyl shift. So this methyl group here will kind of shimmy down here. So this is we'll call this a methide or a methyl shift. And then what we have here is our nucleophilic attack from our chloride that was created earlier. Oh, you know what? Let's draw it over here and do our nucleophilic attack. Right, so it's a little clearer that now we have a tertiary carbocation at this site up top here. Right, so that's where our attack will happen. There it is, right up top there. I'll draw it over here. So our final product will look something like this. So the chlorine has added up here where the tertiary carbocation was. All right, so that's problem 8-10. We'll continue with 8-11 next time.